Hello everyone, and welcome to today's presentation. I'm excited to have you here as we explore Python interview questions and answers for freshers. This is the first slide, serving as our cover, where we set the stage for what's to come. Today, we'll be focusing on control flow in Python, specifically if statements for loops and while loops. Over the next few slides, I'll walk you through key concepts, common questions, and helpful tips to prepare for your interviews. So let's get started. On this slide, I want to emphasize that only the first true conditions block will execute in a series of if, elif, and else statements. If none of the conditions are true, then the else block runs, but only if it's present. It's important to remember that Python requires an expression after the if statement. You can't write if without a condition, or if with no condition following it. For example, in this code snippet, we start by checking if x is less than 10. If that's true, Python runs the print statement inside that block. If not, it moves on to the elif, which checks if x is between 10 and 19. If that condition is true, it executes that block. If neither condition is true, the else block runs, handling all other cases. The key point is that once Python finds a true condition, it executes that block and skips the rest. You can have multiple elif branches, which are short for else if, allowing you to check additional conditions sequentially. Remember, indentation is crucial here. It's how Python knows which code belongs to which block. So, in summary, the if statement checks the first condition, and only the first true conditions block is executed. If no conditions are true, the optional else provides a fallback. This structure is fundamental for controlling the flow of your program based on different scenarios. In this slide, we see that range 5 generates a sequence of numbers starting from 0 up to, but not including 5. So 0, 1, 2, 3, and 4, this is a common way to create simple loops in Python when you need to repeat an action a specific number of times. But Pythons for loops are not limited to just numbers. You can loop over lists, tuples, strings, and any other iterable object. For example, if you have a string like cat, you can iterate through each character using a for loop, printing out each character on a new line. This illustrates how flexible for loops are. They work with any iterable. The loop automatically ends when the iterable is exhausted, meaning once there are no more items to go through, the loop stops. Sometimes, you might want to exit a loop early based on some condition. Here's where break comes into play. Conversely, continue allows you to skip to the next iteration without completing the current one. In the example shown, we use a for loop to print numbers from 0 to 4, which is a straightforward way to do repetitive tasks a fixed number of times. The syntax is simple. You declare a variable, say I, and assign it to each item in the iterable, which in this case is generated by range 5. Inside the loop, you can do anything with that variable, like printing it out or performing calculations. So in essence, a for loop in Python provides a clean, readable way to iterate over sequences or other iterable objects, making your code both efficient and easy to understand. This is a fundamental building block for automating repetitive tasks in programming. In this slide, we're looking at how a while loop works by adding increasing values of n to a total until that total reaches 100 or more. The key idea here is that the loop will keep running as long as the condition total is less than 100. If at the start the condition is false, meaning total is already 100 or more, then the loop body might not execute at all. It's really important to ensure that the condition will eventually become false. Otherwise, you'll end up with an infinite loop that never stops. To handle such situations, you can use break statements to exit the loop early, or continue to skip certain iterations when needed. In the example, we initialize total to 0 and n to 1. Then, as long as total is less than 100, we add n to total and then increment n by 1. This process repeats, gradually increasing total until it reaches or exceeds 100. This pattern is useful when you want to sum numbers until a certain threshold, and it highlights how a while loop can dynamically control repeated actions based on conditions. Remember, in Python, the syntax involves writing the condition after the while keyword, followed by an indented block that makes up the loop body. So the main takeaway here is that a while loop continues executing as long as its condition remains true, making it a flexible tool for many repetitive tasks in programming. Negative step allows counting down, which can be useful in certain situations. The range function does not generate the entire list at once. Instead, it creates a range object that generates numbers on demand. This makes it very memory efficient, especially when working with large ranges. For example, in a loop like for I in range 1, 6, it will print numbers from 1 through 5. When we use range in a loop, it helps us iterate over a sequence of numbers easily. You can create a list from range by wrapping it in list, like list range 5, which gives you 0, 1, 2, 3, 4, or list range 2, 6, gives you 2, 3, 4, 5. You can also specify a step like in list range 1, 10, 2, which produces 1, 3, 5, 7, 9. So to sum up, range is a versatile function that generates an immutable sequence of integers. It's commonly used in for loops because it allows you to control the start, stop, and step values easily. You can use 1, 2, or 3 arguments. With one argument, it counts from 0 up to, but not including, the stop value. With 2 arguments, it counts from start up to stop minus 1. And with 3, it includes the step value, which determines the increment or decrement between numbers. Overall, understanding how range works helps you write more efficient and readable loops in your programs. Let's talk about list comprehensions. They are a powerful feature in Python because they are more concise and often faster than traditional loops. The general form looks like this: expression for item in iterable if condition. Essentially, you write an expression that defines what you want to include, then specify the iterable you're looping over, and optionally add a condition to filter items. For example, instead of creating a list of squares with a for loop and append, you can do it all in one line with a list comprehension. So, instead of writing a loop that appends x squared to a list, you just write x asterisk asterisk 2 for x in range 10. It's much cleaner and easier to read. You can also create other types of comprehensions, like set comprehensions using curly braces and dictionary comprehensions with key-value pairs inside curly braces. And for generators, you use parentheses instead of brackets. Here's an example: generating a list of even numbers from 0 to 19. Using a list comprehension, you'd write x for x in range 20 if x%2 equals 0. It's a quick way to filter and generate lists based on certain conditions. In summary, list comprehensions are a concise way to generate lists directly, combining the loop and condition into a single, readable line. They are a key tool for writing efficient and elegant Python code, especially when working with data transformations. Let's take a look at this example with a for loop running from 0 to 4. Inside the loop, there's a condition. If I equals 2, the continue statement is executed. This means that when I is 2, the rest of that loop iteration is skipped, and the loop moves on to the next value of I as a result. The numbers 0, 1, 3, and 4 are printed, but 2 is skipped. Now, in a different example, we have a loop from 0 to 9, and inside it, if I equals 5, the break statement is used. Break immediately exits the loop entirely. So, the loop stops running once I hits 5, and only the numbers 0 through 4 are printed. The key takeaway here is that break is used when you want to stop looping altogether, like when you found what you're looking for, whereas continue is used to skip over certain cases but keep looping. Both are useful tools for controlling the flow of your program, especially when working with loops. They help you manage your code more efficiently and make your logic clearer. So let's dive into how if statements and loops differ when it comes to control flow. An if statement is like a decision maker. It looks at a condition, and if that condition is true, it runs a block of code just once. If the condition isn't met, it skips that block altogether. It doesn't repeat, it just makes a choice based on the condition. Loops, on the other hand, are all about repetition. They let us run the same piece of code multiple times, either a fixed number of times or while a certain condition holds true. For example, a for loop iterates over an iterable like a list, while a while loop continues as long as a condition remains true. Now here, where it gets interesting, you can combine these control structures. Inside a loop, you might use an if statement to process only specific items, filtering what gets executed each time. This makes your code more flexible and efficient. It's also important to note that if statements run only once per condition check, whereas loops can run multiple times, and they often include control statements like break and continue. Break exits the loop early, and continue skips to the next iteration. Both are useful for controlling the flow inside loops. So, in the big picture, while if else structures help us make decisions, and loops help us handle repetitive tasks efficiently, understanding how these work together helps us write clearer, more effective code. In this slide, we're focusing on how the pass statement helps us avoid syntax errors that occur when Python expects an indented block. For instance, when you create a loop like this, with for in range 10, followed by a pass statement, it means the loop does nothing but is syntactically correct. Similarly, with classes, if you define an empty class with just pass, Python recognizes that as a valid, empty class. The same applies to empty loops or conditional statements. If you have an if-sum condition, and no code to execute yet, you can add pass as a placeholder. So what exactly is pass? It's a no-op statement, meaning it does nothing when executed. It's useful when you need to satisfy Python's syntax rules, but haven't implemented the actual code yet. Think of pass as a placeholder that allows your code to run without errors, giving you a spot to come back to later. This makes it a handy tool during development or when you're planning your code structure but haven't filled in all the details yet. It's a simple but powerful way to ensure your code remains syntactically correct without having to remove or comment out parts just to avoid errors. Thank you so much for your time and attention today. I truly appreciate your engagement and interest in the topics we've covered. Remember, the key takeaways are the importance of understanding the core concepts, applying them effectively, and continuously learning to stay ahead. I hope this presentation has provided valuable insights and inspired you to take the next steps. Once again, thank you, and I look forward to connecting with you all in the future.